This is the grade 11 lesson 1.3, the sine law, example number 1. So just as a quick recap of the sine law, you've gone through the sine law activities that are posted on D2L. Really quickly, what we've been going over in the first two lessons is working with right angle triangles. So finding side lengths and angles of right angle triangles. And we've got two tools that we can work with. So this is going along with the handout, 1.3 the sine law. Make sure you've got that from me. So there's two tools that we can use when we're solving right angle triangles. And one of those tools is what we've been working on the last two lessons, which is SOHCAHTOA. So that is the sine ratio, cosine ratio, and tan ratio. The other tool that we can use, we learned back in grade 10, which is the Pythagorean theorem. So this only helps us with side lengths though. So if you can remember from grade 10, it's a squared plus b squared equals c squared. So if we see a right angle triangle, these are the two tools that we can use. But if we see a non-right angle triangle, so anything that doesn't have our perfect 90-degree corner like this, we've only got two options. We cannot use SOHCAHTOA, we cannot use Pythagorean theorem. We've got two other tools that will work for all triangles. So the two tools are the sine law, not to be confused with sine ratio, opposite over hypotenuse. This is something different. And the cosine law. So when we are stuck with a triangle that's not right angle like this, we cannot use SOHCAHTOA. We cannot use Pythagorean theorem. We have to use sine law or cosine law. So we're going to, before we go into example number 1, I just want to quickly take a look at the sine law here. So it's up on your handout here. So this is the sine law. Don't be confused that there's 3 fractions. I'm going to show you how to use them. Just as a quick note though. So up on the top here, these are side lengths. These little a, little b, little c. And at the bottom here, we've got angles. So I'm going to show you what I mean by that. Let me just undo this. Okay. So what I want you to do is, there's a triangle already drawn on your sheet. I want you to find space to draw another triangle. So I'm going to draw it like this, and it should not be a right angle triangle. So I'm going to draw something like this. There's no right angles in here. Before we use the sine law, you have to know how to label a triangle. So angles are denoted with a uppercase letter. So we're going to follow what we have in the sine law, A, B, C, and do the exact same thing on our triangle. So I'm going to pick any angle. I'm going to start at A. So why don't I pick this angle? So I'm going to call this big A. I'm going to call another angle big B, and I'm going to call another angle big C. It does not matter the order that you label, as long as you use uppercase letters. What's most important is the side lengths. So how to figure out the side lengths is you take an angle and you go across. If this is the angle big A, then this side length has to be little a. And we've got our big B, we're going to go across, and that has to be the side length little b. And then we have our big C, and we're going to go across, and this has to be our side length little c. So when we label our triangle, it's going to look something like this. We've got our triangle. I'm going to choose this A, this B, and this C. So then therefore this is little a, this is little b, and this is little c. So if we go back to our equation, if we go back for our equation for sine law, we notice all of the top, these are all side lengths. Little a, little b, little c, those are side lengths, and at the bottom we've got angles. So now if you've got all your notes done, we are ready to get started on example number 1. So example number 1 is written on your sheet, and it looks like this. And the question says, find the length of AC to 1 decimal place. So we are looking for the length here, length AC. So we can do that, no problem. So, is this a right angle triangle? I don't think so. I don't see any. That could be a right angle, but I don't see anything denoting that it's a right angle. So we know we can't use SOHCAHTOA. We can't use Pythagorean theorem. So we are stuck with sine law and cosine law. Since I haven't taught you cosine law, we're going to use sine law. So right away, I'm going to write out sine law. A over sine big A equals little b over sine big B equals little c over sine big C. So we have to finish labeling this triangle before we can plug in what we know. So if this is big A, this must be little a. And then this must be little b. And then this must be little c, because we're just going across the triangle. So now what I'm going to do is I'm going to plug in the information that we know. Do we have little a? Yes, we do. It's 36 centimeters. So I'm going to put 36 all over. Do we have angle A? It looks like we don't. But actually, we've got two other angles here in this triangle. And one really important piece of information you need to know is that all the angles in a triangle have to add to 180. So write that little note for yourself. Okay, so I'm going to write all angles in a triangle have to add to 180 degrees. So if we want to find out angle A then, so let's figure this, angle A is just going to equal 180 minus 48 degrees minus 25 degrees. And that's going to give us 107 degrees. So we actually do know angle A. I'm going to put it in there. So as I continue to write out our equation, we do have angle A. It's 107 degrees. So I'm going to keep on going now. Then we've got little b. Little b, we have no idea what it is. So I'm going to write out little b. See? We're not given little b. All over sine, do we have angle B? Yes, we do. It's 48 degrees. So here we go. 48 degrees. And do we have little c? No, we do not. So I'm going to write little c. All over sine of big C. We've got angle C, so I'm going to put sine of 25 degrees. So the next step to use sine law is that if you notice, we've got 1, 2, 3 fractions, but we only need 2. So the 2 that you're going to pick, one of them has to be a complete fraction, which means that we don't have any unknowns like this. The other fraction has to contain the thing that we're looking for. So first, let's figure out which is our complete fraction. If you take a look at them, if you can see it, this fraction is complete. We know the top numbers and we know the bottom numbers. This one is incomplete because of the b, and this one's incomplete because of the c. So one fraction's picked. The other fraction that we pick has to have the thing we're looking for. Remember what the questions asked us. We are looking for this side length right here. So we are looking for b. So here are two fractions that we're going to use. This one is complete, and this one has b, which is what we're looking for. So let me erase my arrows, and here we go. I'm just going to erase this here so I've got some more room. So the next step that we're going to do is we're going to rewrite these two fractions underneath. We're going to forget about this one now. We don't need this yet. So we're going to use 36 all over sine of 107 equals b over sine of 48. Okay, so now all we need is a little bit of algebra that we use in SOHCAHTOA. Remember that we need b by itself. Okay, so we are asking ourselves, what is in the way of b being by itself? What's this sine 48 right here? If this sine 48 went away, we would just have b all on its own, which is what we want. So we're going to take this sine 48 and we're going to bring it to the other side. So everyone, once we bring this to the other side, it's going to to bring this to the other side, we're going to use the opposite operation. So this is a divided by sine 48. So when we bring it to the other side, it's going to turn into the opposite, which is multiplying by sine 48. So it's going to look like this. Let me bring my screen down. Okay. So it's going to look like sine 48 times whatever is on this left side. So we've got 36 divided by sine 107, and we've got on the right side just b left. So all you're going to put into your calculator is sine 48 times 36 divided by sine 107. So you don't need to use brackets if you don't want to. And once you put that into the calculator, you're going to find to two decimal places that b equals 27.98 centimeters. And if we look back up at our triangle, if this side was 36 and this side is 37, that seems like a reasonable answer to us. If you think you've mastered this example, please click on the next video to take a look at example number 2, where we're going to look at angles.